Welcome to the Practical Futurist podcast, a bi-weekly show all about the near-term future with practical advice from a range of global experts to help you stay ahead of the curve. Every episode answers the question, what's the future of? With voices and opinions that need to be heard. Your host is international keynote speaker and practical futurist Andrew Grill.
Welcome to episode 4 of season 2 of the Practical Futurist podcast. Today we have a special guest, Paul Scanlan, who is CTO of Huawei's Carrier Network Business Unit. Paul's career has been linked to technology, specifically information and communication technologies. A fellow Australian, he was educated at University of New South Wales and started his career with Australia's state-owned OTC, a precursor to my old stomping ground of Telstra. With more than 30 years' experience in the telecom and IT industries, Paul has broad experience across most technologies, having worked in a variety of senior roles across technical, commercial, operations, sales, marketing, program management and R&D. Welcome, Paul.
Thanks very much, Andrew.
Now, I've just been very fortunate to sit around a round table with a bunch of influencers, and you were quite candid about, the challenges that you face in the industry. But this podcast is about the future of, and I wanted to talk about the future of 5G. So for my listeners out there that may be in markets where 5G isn't live or it's just been launched, how would you describe 5G and why is it better than 4G?
Sure. Andrew, this is probably the most misunderstood technology. It's been bandied around as being everything from the evil of the world to the savior of the world, right? And I think the answer probably is leaning towards the latter, which is it's something that really will transform. So I like to think of 5G as a platform for transformation, right? So I won't talk about it as a speed thing or this thing or that thing. I'll just talk about it as a platform for transformation. Everybody says, 5G, it's faster, it's this, it's that, and everything else. When we talk about how do you operate 4G and how do you operate 5G, when we operate 4G, generally we designed it for this thing called 20 megahertz of spectrum, okay? Because in 3G it was 5 megahertz chunks of spectrum, and therefore more megahertz means you get more spectrum. Generally, you get more bang for your buck. When we talk about 5G, we're starting with 100. Doesn't mean it can't work in 80 or 70 or 60 or 50 or 10.
Yep.
But it was originally thought of, let's try it for 100 meg. 100 against 20, it's about 5 to 1, if I'm not mistaken.
Yeah.
Now, of course, you've got the uplink and the downlink, so you have maybe it's about 2 or 3 to 1. Let's put it in, call a spade, right? So you have about 2 times or 3 times more spectrum. So you're already not comparing 4 and 5G, like for like. We learnt, Andrew, many years ago, 5 years ago, in doing a thing called WTTX, wireless to the something. Mm-hmm. We learnt that we could provide wireless communication as a sort of an alternative, or certainly a better time to market than fibre, by deploying wireless-based technologies to provide home-based broadband solutions. Yeah, because you put an antenna in and you can sell it, sort of cash and carry. You get 5 megabits per second, 10, maybe 100, right? Now this fixed product is competing with the mobile product. The second one is the bandwidth is not there, so you don't really have enough resources. But we learned very quickly that if we were able to put more antennas in, and we called it massive MIMO, then you would end up with a better result. Suddenly you can offer not 300 customers 10 megs, you could offer 3,000 customers 10 megs. And the more customers, more ARPU, more money. Simple. It's all about money.
Yeah.
So now comes 5G. So 5G, the first thing we do is say, hang on, we've already got some empirical evidence about how much more efficient having 100 megahertz of spectrum is. In this WiMAX area, we're using 2.3, 2.5 gig. We've picked a different spectrum, 3.5 gig, which means 3.2 to 3.6, 3.8, maybe 4.2 to 4.6, 4.8.
Just for our listeners, the higher the frequency, the more efficient it can be because you can get more bandwidth through the high frequencies.
Well, you get larger amount of contiguous spectrum, yes, and understand a little bit about how breaking spectrum up into blocks becomes very inefficient. But if you have a big block of spectrum, absolutely right. And that's why the millimetre wave, the even higher stuff, is even far more beneficial because you have a clear 1 gigahertz and suddenly, wow, instead of 5 megs, I've got 1 gig. Well, simple physics tells you you're going to get more bang for your buck. Yeah. So 5G comes along. We're starting, the premise is 100 megahertz, a huge leap ahead of 4G. And we've got these improvements in efficiencies. So that's what lent itself to the high throughput. But wait, there's more, right? And the more bit comes to about things like latency and massive connections. So we could already see that the challenge is always the always the latency at the air interface. And the reason for that is because you could imagine from a base station, probably in developed countries, you can have fibre back to the core network. Fibre back to the core network, 5-10 milliseconds end to end.
It's
UK end to the top, right?
Yep.
Japan top to bottom is 10. Roughly, these are sort of rough guidances of how much delay you have across these areas. But if you want to do things that are more interesting, like connected car, you don't need 5G for a connected car. But if you want autonomous driving, it's one of the options. Yes, you could use other methods, but that's not the most important one. But if you take a robot, right? I don't know if you've ever shook the hand of a robot with articulated digits. But the first thing is, if you want, when 100 kilos of metalwork comes towards you and puts something out, the first thing you do is step back.
Of course.
When you put your hand out and you grab it, if the latency is not really sharp, then by the time it gets feedback and squeezing your hand, it's probably too late.
You might crush your hand.
You got it. So
Right.
we need latency. So there's
Yeah.
a practical example,
Yeah.
yes? But you have more. Certainly the connected car within a couple of meters, the shorter duration, robotics, interaction. Let's talk about the medical profession. If you wanted to do telemedicine, remote medicine, yes? So between a practitioner, a highly capable person. Let's take a simple one, like, it's not really simple, but let's take ultrasounds, yes? So you have an expert, a technician, generally woman or man, is sitting there with, a couple of $100,000 worth of equipment. What about the village that's, 200 kilometres away or 300 kilometres away? So we just discussed about this thing called latency. Well, what about if I wanted this person to do some remote, monitoring of a man or a woman or something on the abdomen? And we've got these tactile feedback devices now, yes? But the person is a couple of 100 kilometres away. So you imagine there's a basic person, triage nurse, strapping this thing to your body for a couple of $1,000s, which is cost effective, and you've got the expert with all his brain power and all his analytics back up here with his scopes and everything, and now he presses. And 200 kilometres later, it's pressing on you. And then by the time he gets the feedback, he's got to realise that, I shouldn't have pushed too far. Because
It's the robot problem. You don't want to crush the patient.
You got it. So
Yeah.
this is the same problem. So this is the latency thing. So here's a couple of industries and a couple of sectors where you can feel that latency would be important. Robots inside a factory.
Yes.
Today, factories, Andrew, haven't changed in 150 years. Everything is serial from the day we industrialised in the UK, right? I give you the material, you do your bit, you pass it to him, he passes it to her, she passes it to him. What happens today? Robotic plant. Robot A does this, passes to robot B, passes to robot C. So let's suppose this boardroom that we're in now, which will be vacant in a couple of hours, is the next factory from 12 till 6. In come the robots, wheeling themselves around, connected with 5G. They're all made from different companies, Kawasaki, ABB, etc. Yeah. And they're all connected to the cloud via 5G. So the latency is really small. And of course, if you take beyond this IoT thing of a few connections to multiple connections per person to devices everywhere, lampposts, ties, dresses, salt, pepper shakers, everything, the cup of tea bags, all connected. And they will be. You might think it's stupid, but today it'll get down to something, a third the size of your fingernail. Then everything's connected. If you have that competition of connectivity of things in a cell, a mobile cell with people, you have come back to the first problem of fixed wireless access together with mobile. Competing for resources. And it's signalling resources.
Yeah.
And you won't have a few thousand people per cell, you might have hundreds of thousands.
But the thing with IoT is you don't necessarily need the speed because some of these things are transmitting at low data rate. But if you've got millions of them in the same spot, they all want to compete for radio spectrum to say, hey, I want you to give you my data.
You got it. And so you're quite right, Andrew. The data rates are pretty small, less than a couple of kilobytes. But you have a lot of them, and it's the signalling. I've got to wake up and I've got to communicate to the thing. And so it's a bit like signalling overhead traffic. It's competing for this small amount of data. So there's a lot of optimization, bottom line. So we factored that in. So that's why you have speed, latency, and throughput as the three key components of 5G. But what nobody ever talks about is the social impact of 5G. And the social impact directly is about energy. So, today we're at the product and solution launch of Huawei. And we announced that we have a 5G product that is now, it went 1 year ago, 40 kilos to 25, from 200 megahertz bandwidth to 400 megahertz bandwidth, but also consumes about the same amount of energy as a 4G site. Yes. So you've just gone for something that's 20 to 100 times better for the same amount of energy. So some of the analysis that's been done by, very specifically by a company called STL Partners, a consulting company here in the UK, and they've done some analysis based on Huawei's products and all the competitors' products and looking at all the networks around the world and their energy consumption. And a very simple tagline is that if you keep building 4G networks, you double the carbon footprint of the planet. But if you use 5G, it flattens out and it starts to reduce within 5 years. That's not a bad reason for deploying 5G above all the others.
I think you're a great storyteller. I said I've just had the opportunity to spend an hour and a half in the room, and you mentioned a point about your base station equipment going down in weight. You told a great story about why that weight. Now, people know about Huawei for all different reasons, but I love this story about how the thing dropped in weight. Would you care to share that story?
Sure. So I was at a meeting in headquarters, and the CEO was sitting at a table with a number of us, including the product R&D director, and the product R&D director was showing the new version of the first 5G base station that we were going to be launching in a few months. And the weight was 45 kilos, Andrea. And he said, knocked on the table, "What do you mean 45 kilos? Don't you understand occupational health and safety in Europe?
Yeah.
It's 40 kilos. Everybody looked at him, what does that mean? And he said, you need a crane. If you need a crane to install this, do you know how expensive it'll be for our customers?
Yeah.
They won't, and how the time delay plus the expense and everything's, the wrong targets. The capital equipment cost will be too high. 3 months later, the R&D engineer came back in, 40 kilos. Right, thank you very much, 40 kilos. We launched it now with 25 kilos, and he just stood on stage and said, do you know why it's 20 kilos? Because a person is allowed to carry a 20 kilo product and install it. And, so we're always thinking about how do we improve the customer's business. It's not about, we've got a great product, you want to buy it, or you should buy this product because it's got these features. We're always thinking about from the customer's perspective. And generally, everybody has the same KPI. They have 4 KPIs. It's called revenue, profit, brand, and market share. You want all of those things. That's what you want, right? That's the key metric. So we always think about those components whenever we're building products or solutions or focusing on customers and things like that. Yeah.
So we're both sitting here in London. Just for some context, we both were going to go to Mobile World Congress next week at time of recording in Barcelona. And due to the tragic consequences of the coronavirus, we're now not going because it's been cancelled.
Yes.
I remember back in 2009, I've been going to MWC like you for many years. 2009, it was all about 4G and LTE.
Yeah.
And I think probably right now we're at the same point again where we've got this new technology, we're trying to leverage it. I remember, though, that when 3G was launched, probably 2006, the use case was we can make video calls.
Yes.
I think I've made 2 video calls in my life. So if we were to be at MWC next week, what would the chatter have been about 5G, not just from your organisation, but where do you think, and this is more towards the ecosystem question, where are people unlocking the power of 5G and making it beyond carrier-grade equipment and actually making people's lives better?
Yeah, really. So, I would say the 4 lowest hanging fruits, I guess, of 5G application in industry. And this is, as I say, really comes down from a lot of the analytical work that consultants have done, not on behalf of Huawei, on behalf of probably all the other vendors as well, and Informa and all these sort of analytic companies and research companies. It's really, first of all, does an industry understand 5G? Because, you're doing podcasts, example, you might be a journalist. So what do you understand by 5G? Well, I understand nothing. So no point talking to the journalist. Just example, right?
Yeah.
Same sort of thing you could say in the health industry, right? Not well understood 5G and what could it do to my industry. But in manufacturing, very different. And the reason it's different in manufacturing is because of this thing called connectivity.
Yes.
Because the robots today are connected. And they're connected by sensors that are in the robotic arms and the robotic equipment for one specific reason, that's predictive maintenance. Okay, they do a lot of other things, but predictive maintenance is the key one. So when we speak to the executives of these manufacturing companies, and we did it not just in UK and Germany, we did it in Brazil and Indonesia. So we wanted a sort of a developed and developing market perspective. First question is, do you understand 5G? And the answer is yes. What do you expect it to do for you? I expect it to do this and this and this. Low latency, massive connections, and ultra reliable and ultra secure.
Yep.
They weren't so thinking about that.
Really?
Not from the first perspective.
Okay,
you see,
right.
In the manufacturing industry, it's about the connectivity bit. So what they wanted is they want to go from 2 or 5 sensors to 10 or more sensors. Well, you can't do that if you've got a Wi-Fi network or a Bluetooth network. The connectivity is complicated. It doesn't give you a guaranteed grade of service nor security of service.
So just on that, the question was going to be, why wouldn't you use Wi-Fi in a factory? And so why is 5G more secure than Wi-Fi?
Yeah. So that's that I'll come back down to. Maybe I'll wrap it up with that one because I'll sort of give you the idea that the industry understood these sort of 4 areas, right? So their target is predictive maintenance. And the reason for that is 1% improvement is about $150 billion globally.
Yeah.
Now that's got a downstream effect for everything. It means the products are better, cheaper. It means that the company does consume less energy. So you're quite right, it's a downstream flow-on effect, and they understand that. But in terms of 5G, and maybe we come back down to the other reason that 5G was developed and when we were considering it, and despite all the nonsense you hear, it's quite frankly, it's nonsense, right, in the press about security in Huawei and the way it's been intertwined in 5G security in Huawei and all those sorts of things, absolute nonsense. When we engineered 5G, we engineered it to be far more secure than 4G. Let me give you a practical example. Every time you turn your mobile phone on, obviously you have signaling connection to the base station. In 4G, it's pretty easy. How easy? A researcher at a university. So, researchers at a university, they're smart, they have no money. So somebody who's got no money but is capable can build it on a laptop. And he can spoof the base station, and as soon as he just sits back and listens, and I've got your...
Captures all your
captures
traffic.
all... Yep, so I know exactly who you are, where you are, and all that sort of stuff. So it's not that secure. So what we did in 5G is we did two very specific things at this air interface between the handset, the smartphone, and the base station. And the first thing we did was we encrypted everything. And we encrypted in 256 bits. And if your listeners understand, and probably you can do some research, you go and calculate how many hundreds of thousands of years you need, even with a quantum computer. So you're not going to crack it too easily, first bit. So we encrypt it. Second thing we do is we put it like a tunnel, a bit like an SSL, a VPN.
VPN, yeah.
Yeah, people understand the VPN. So it's a secure layer. We put that straight through. And it goes straight through the base station. So it doesn't matter if it's a Huawei or any other vendor's base station. Nobody sees the traffic, right? It's a tunnel. You can't see into a tunnel. So that goes all the way through back to the core network. So that's the second thing we did for security. The third thing we did, and people have heard this concept of network slicing. In the core network, we already identified that we're going to have this huge amount of opportunities for different type of metrics to be monetized and to be specific for different industry sectors.
So video traffic versus voice versus IoT traffic, for example.
Could be, yes. Yeah. And maybe we take the industry. We could say maybe a secure layer for security services, maybe another one for the health industry, maybe another one for the gamers, the other people for the mums and dads, that sort of, so you're by industry, by application type. You could split it by massive devices, IoT, as you mentioned, yes, you could do it that way. You got another layer for high throughput, VR sort of thing, or massive file transfer. You could do anything you liked. It has some restrictions by the number of layers, but the principles were slice the network. Now, we never did that in 4G. So we never had to think about security by service layer. So that's what we engineered and designed in the core network. So there are three areas where we enhanced security to prevent very specific problems. So that means a 5G network, it's going to be very, very difficult to snoop or eavesdrop. That's a good thing. That's a good thing from privacy perspective. It also means that perhaps administrations need to communicate with other administrations and request data rather than doing it another way, perhaps. Anyway, we won't go there, this podcast. Yeah. But you get the idea, right? So there are three areas where we want enhanced security. And I think yourself, when you turn on Wi-Fi, you get what you pay for. It's free. So as soon as it asks and says, I want your name and details and everything else in this hotel to be able to connect to the Wi-Fi, you say yes. So suddenly you've given all your data away. Unless
you're like me, that's a subject of another podcast, I never give my real name or real birth date to any system. And surprise, surprise, they let me in.
So you're saying there's a lot of fake data out there, right?
Yeah, a lot of fake data. I like talking about things in threes, but with 5G, we've got to go to 5. So Can you give us 5 reasons to trust 5G?
Let me explain why I picked the first one as first. I didn't necessarily pick it first, but why I wanted to present it first. And it's about electromagnetic radiation. Right? So we thought, why start with the use cases and all the easy stuff, or all the things that everybody's heard from? Why don't we talk about the real issues? Because that's what was topical at the time. For the last 12 months, everybody's been out there. It'll fry your brain. It'll do this. It'll do that. I've got, great engineering friends in Australia. I don't want that. Here we're sitting on the beach. You're playing with your 5G phone, and it's going to fry me because I'm sitting next to you.
Where's the proof?
Very good question. So I did 3 things. The first thing I said was, let's bust this myth.
Yep, good.
And the first bit was, first you need a bit of fact. So the first bit of fact was, let's talk about what is EMF and where is it and all this thing called spectrum. Put it in perspective so people have a visual aid to understand what is this stuff we're talking about. And the second one was to really show the original research, yes? And the idea wasn't to discredit anybody. The idea was just to say that the research was done at a particular time by people for a particular purpose, and it was done a certain way. So that's how it was. But it wasn't done in a rigorous way to demonstrate real-life situations. So, you do it on mice cells, brain cells in a lab, you get one type of result.
Walking down the street is a different use case.
Absolutely different use case. Look, we've had mobile phones strapped to our ears for how many years, right? 30 years. I think we're all mostly normal. And we've all been looking at laptops, and strangely, nobody has RSI
but ironically,
anymore.
Wi-Fi 2.4 gig isn't a microwave oven 2.4 gig.
Though they're very similar.
So you shouldn't be more worried about Wi-Fi and microwave ovens.
Do you not remember the first microwave ovens that came out? The next hottest selling item was a microwave radiation leakage detector, right? Because everyone put them. And what did it show? There's no leakage.
Yeah, because it's a Faraday cage.
That's right. So it was not happening. Let's talk about facts. So I just wanted to highlight the facts.
Yes.
What is this thing called EMF, and where does this spectrum that we talk about fit in with respect to radios and televisions? And by the way, a lot of the research shows that they give off a lot more radiation than what we're talking about here. But the most conclusive proof is, let's talk about the World Health Organization. The GSMA and other studies have also demonstrated this, that there's no conclusive proof that it does anything. And I thought that was a good thing to start with, rather than have this scaremongering, it'll do this, I heard that. How about we just refer to a medical expert, an industry medical expert, the World Health Organization, who has studied it, analysed it and published it. And I think that then, so what the point I'm making is, let's clarify and let's start publishing the truths about a lot of these things, which is, I think, what you wanted me to start with, right? So EMF, very important. Let's state the truth. It's not about saying somebody is right or wrong. It's about saying that the evidence today demonstrate that it is unlikely that there's any, from whether it's 5 or 4 or 3G. That's not the point at all. So that's why I started with the first one. You can trust 5G that it's not going to fry your brain, if you want to put it that way. And the second one I wanted to talk about was about security, because that is also the current hot topic. And I think I've probably addressed that, we've tidied those sorts of things up. So 5G, much more secure than 4G. In the third area, the one I sort of also started to touch on, is about energy efficiency. And that's really the concept that if you have demand, you need to service demand. And if you're going to build networks and build expansion and everything, you need to use the thing that's the most efficient. And in this case, energy efficiency. And the reason we focus on energy efficiency, quite frankly, is because if you look at an operator's operating costs, his CapEx and his OpEx, and just look at the per site, you'll see roughly between 60 and 67% of every operator in the world is OpEx, not CapEx. So it's not about how expensive the equipment is, it's about my operating costs.
You've got to run it every day. You've got to lease the site, you've got to power it, you've got to secure it.
You got it, yep. So the backhaul, so the backhaul is running roughly 17%. The power consumption is around 12%.
Right.
And the site leasing cost is about 30%, rough numbers, yes? So, 5G can fix 2 of those 3, right? It'll fix the power, and it'll fix the site. The reason it fixes the site is because in one box, as we demonstrated downstairs, supports 2, 3, 4, 5G, every single frequency known to man. It's in one box and it hangs on anything. The third one really was around efficiency, yes? The fourth one is all about the sort of the industrial applications, if I'm not mistaken, yep? So in this case, that's where I was really trying to show, I think by 8 different industry sectors, what the GDP contribution 5G could make. And that's the one that shows quite convincingly that, manufacturing run at about 4.3%, transport distribution running around 4.7 or something, health 1 point something percent. Okay, it looks less on health than on manufacturing, but you have to understand that they're pretty big industries, so 1 or 2% of $1 trillion is a lot of money. But also it represents the maturity of understanding of those industries, of what 5G can do to them. And that, remember, there's no lateral thinking yet, so we haven't built an environment where all these things come together, and partners and innovators and come in with all this technology, both IoT, 5G, even cloud and AI, quite frankly. So putting all those things together, you get a lot of different ideas. Then we move into the last one, which is really about the concept of digital systems. And the reason I talk about digital systems is because you imagine today people are connected, and we had connectivity for a long time. We're just doing SMS and voice. Suddenly now we've got this thing called broadband, and you just mentioned maybe we're doing some podcasts, maybe some video, maybe we're interacting with Facebook or somebody else. And so suddenly you've got a couple of different things, but it's still focusing around people. Now you're going to have things. So we're going to have connectivity between things. So all the chairs are going to be connected. But all the people who sit on them with their pants are also going to be connected.
And the reason why is we want to know if there's someone sitting in the chair or not. So this morning when the room was very busy, you could have said there are 14 seats down the front that are available because the chair is telling some system that it's available.
And you can see it on an app and you can see which chairs are available. We can do those things very easily. So the key is this thing called collaborative analysis. So that means collaboration, not between people, collaboration between things. Well, how do things collaborate? Well, they collaborate via AI, but things and people. So imagine a simple day in the future, and people ask me, what do I think of the future? Well, let's suppose all the cars are connected, connected and driverless cars don't crash, right? You crash into me, I crash into her. That's the reality. So a smart government would say, well, hang on, I'm going to revoke all those licenses and rescind all those registrations, all those cars. We're only going to have autonomous cars, but there's more. If all the traffic lights were connected, or actually we don't need traffic lights. The reason we don't need traffic lights is because this AI, which has connected all the people and all the things and all the other bits in the cars, now knows that, Andrew, you can leave in 3 minutes because your car is parked in B2. Paul, you can leave in 7 minutes because you're in B7, and the way you're going to drive, and and Susie can leave at this time and Jenny can leave at that time, because we know that you've said you're going to go home to here, and we know where you are, and we know the traffic. We know the traffic from here, we know everything. And therefore the best route to optimise this, and you won't cross the street at the traffic lights because you don't need traffic lights, because where I'm going to send you to cross, there'll only be 3 cars and there'll be 20 people. So therefore, people have the priority. But in the other intersection, there's going to be 20 cars and 3 people. So to optimise everything, this is what we're going to do.
Well, actually, I'll go further. As a futurist, I talk about when we have autonomous cars, basically, we won't be allowed to be on roads that aren't autonomous only. So
Correct.
Routes like fences, you're dead right. With 5G allowing cars to speak to each other, you don't need traffic lights because the cars know where they are.
That's right.
So I think in our lifetime, we will not be allowed to step onto a road because there'll be autonomous lanes only. And I think that is a real thing that can happen.
Yeah.
All sorts of issues as well. What's one question you're most frequently asked about 5G and about Huawei as a company?
Perhaps more recently, I'll take the last question, is given the geopolitical things, isn't it easier just to give up in certain markets rather than to carry on? But that's not in Huawei's nature. Yes,
No.
We've been trying and fighting and developing and inventing and delivering for customers. $17 billion in R&D, customers that love us. You don't get 91 contracts in 5G by accident.
Yeah.
You don't control 20% of the intrinsic 5G patents by accident, and you don't get 87,500 patents globally by accident.
Having worked at IBM, who are very proud of their patent, that's something that companies see as real value.
Of course they do. And that's probably why we are misunderstood. Maybe they don't want to understand us. But, private company, nobody believes that, right? I've worked in a company for almost 12 years. These are the things that we do, right? I see the passion in the company to try to deliver the promise that the founder sets as the vision, which is, connect everybody intelligently, make, improve life, improve the globe, improve everything. That's the target. So, very misunderstood company, and because of that, the questions that come to us are, well, you couldn't have done it that way. You must have stole this. You must have done all of this stuff. Yes. Now, is it all done because of geopolitical targets? Most likely, but that's not for me to say. What I can tell you is that we get these sorts of questions relating to, trust and Huawei, and it's lack of understanding. You fear what you don't know, right, Andrew?
Yeah.
So what we've embarked on, a campaign over the last 12 months, is called Trust and Transparency, or Openness and Transparency. And the reason for that is, we're a technology company, 80,000 people in R&D, half the company's in R&D. We're technologists. We talk to the CTO, the technical officer of telecom companies. That's where we make our money.
Yes.
Suddenly we have to understand, we have to talk to journalists and podcasters and KOLs and the government and the this and the that.
Wow, all these crazy questions you're asking.
We didn't know that, right? You tell us how many dB. We know the answer to that immediately, right? Now you tell us, so what's your...
Well, you're dealing in noise. This is now geopolitical noise, and you can't really attenuate that very easily.
It's very, it's a challenge. So that's probably the most difficult part of the questions that I get from generally the industry. The question about 5G. So the most is really relating to the B2B industry, okay? Because they've sort of settled on the B2C stuff. They've understood that it's an efficiency, video, data, throughput, terribly important, reduce churn, keep customers clear. That's the business they understand. But the question really now comes around to, well, okay, so we can transform industry. Well, how do we do that? Well, the first thing is mindset, right? You've probably got in an organisation, let's take a simple organisation of 1,000 people, there's probably a lot of engineers in there, probably a lot of B2C marketing people, but just now I've told you manufacturing, health, let's take transport and energy. Let's talk about renewables perhaps. Do you have a VP of each of those in your company? Probably not. And if you did you take the doctor from the hospital and employ him? Yes, I did. But does he know how to run a health business with a peanut? Probably not. You see, there's a lot of challenges. So the first one is understanding the business opportunity, the KPIs, the company direction, the DNA of the company, hiring the talent. Haven't talked about technology, right? That's the first thing you need. So you need organisational transformation. You need to think that this is the business opportunity. A little bit of faith, but we've demonstrated those use cases and they work. Yeah. And these industries, at least half a dozen of them, understand that 5G can do things for me. So that bit's gone. So now the question is, so how do I do it, Paul? What should I do first? That's all. Help me with these sorts of areas. And I think that's the reason, one of the reasons I'm here in the UK is to set up this, we've already set it up. It wasn't set up by me, set up last year. But this 5G Innovation and Experience Centre. And what we would like to do is we would like to try and invite lots of different partners and telecom companies and industry players and perhaps academics and other people to come in there with ideas. And we want to demonstrate and prove the use case together with the telecom operator, together with the industry we want to transform, and then take that to market, because that's industrialization of a product. If we copy it here, and why do it in the UK? Well, UK has said we trust you, so carry on doing business here. And therefore we'll invest here. And UK, given the Brexit opportunity, means that they have an opportunity here to try and do things in a different way, perhaps. More local, homegrown ideas here. UK is already surging ahead in renewables and things like that. It still has a very good manufacturing sector. The healthcare sector is a challenge for every country, and not just the UK. So there's a lot of good reasons why we feel that the UK ought to be the place where we sort of start this pioneering work.
So quickfire round, as this is the Practical Futurist podcast, what are 3 things our listeners can do this week to take advantage of 5G?
Ask your telecom operator to deploy 5G now for you, because if he does, he's probably going to reduce the energy consumption. Yep. You should buy a 5G phone, and the reason you should is because it's going to be more efficient. Okay, It's using your technologies, which are better, faster, smarter, cheaper, but they are more green. But perhaps the most important one would be, how about we turn off all this 2 and 3G stuff, right? Because those things are terribly energy consuming. And, okay, I get it that, in developing countries, I've got X number of million people that are still using 2G just to text. I understand that, and the ARPU's $1. But, as Ryan Ding, our CEO, said downstairs, a 5G handset last year was $300. That means during the course of this year, 4G handsets are $20. How do we get a low-cost device into everybody's hand? Because if they are, then a couple of things happen. With this thing called smartphone, people can transform. The farmer wants to know what the cost of the wheat is, or the rice is, or whether the next storm is coming, or the right fertilizer, or how to fertilize, or how to do this. He gets the information instantly. You don't get that over an SMS easily, right? You don't get that over a feature phone. You don't get efficiencies from 3G and 2G. So they ought to be removed. So, if everybody could turn around now and say, I want a 5/4G handset, that would transform things and head things in the right direction.
Paul, thank you so much for your time. I've really enjoyed it.
My pleasure, Andrew.
Thank you for listening to the Practical Futurist podcast. You can find all of our previous shows at futurist.london. And if you like what you've heard on the show, please consider subscribing via your favourite podcast app so you never miss an episode. You can find out more about Andrew and how he helps corporates navigate a disruptive digital world with keynote speeches and C-suite workshops at futurist.london. Until next time, this has been the Practical Futurist podcast.